Wait, are you playing music in the background, or is that me?
In my headphones. Is it picking up on the microphone?
Hello?
Whoa, hold on.
Wait, I don't know.
Does it stop?
Oh, it stopped.
Yeah, so you can, my microphone is picking up the sound in my headphones.
Oh, I see.
It's that loud. Set the 18 joint angles that we care about. Um, That should probably be listed once at the top of the document. Um, put you down for a second because I need to copy you. Grab you. One too many there. There we go. Document top. Edit
Oh, also, by the
this.
way, the Android app that I'm using right now, it's
Uh-huh.
the app is closed sourced, but there's a config file that's you can change some of the parameters, like the dimensions of your robot. But I think something with this code is messed up because when I change it to match my dimensions, the entire thing goes wonky. It just doesn't work.
Huh.
But it does have some pretty cool stuff. Like I think he has the cox. Okay, so the coxa joint, he has a distance between the different coxa joints, and then based on the length of the legs, I think he's somehow able to calculate these like how far the legs needs to go, how far the leg needs to step forward or backwards, and not run into each other.
Hmm. He's got some kind of safety in there. That would be great. I never did have a good safety, so I just guesstimated the numbers and ran it in simulation to make sure that it wasn't crashing. And then when I put it on the real machine,
Mm,
because it copied it perfectly, I was safe.
that makes sense.
Pose is a compact array of 18 doubles. The format is blah, 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 blah. Yes. Perfect. Um, the sequence follows the leg index. You may ask, why do I write comments so early? It's a favor I'm doing to my future self, and young me did it to me so many times that I follow in his footsteps, his great thinking, and try to pay it forward to older me down the road. So now I can get the pose and I can set the pose as a list of doubles, which means I can now instead of putting this in here, I can make nodes that do things and then send them to Crab, and the Crab will follow that animation. And then I just snap in the one that I want. Or like I said, do the blending mode. Um, the other way, well, now that I have set pose, I can set pose and build, just give this 18 numbers right here, and it will snap the whole Crab. Um, The other way is to hard code the motion of each joint, doing this kind of thing.
Mhm.
But so let's see here. For example, let's give this a shot. Standing radius. Our current. I don't have it open. You can go away, and you can go away. Um, the I need the distance. What's the what radius do you want for the feet when they touch the floor when they go to stand up?
What radius? What do you mean?
Okay, I'll try this another way.
Like from the center of the body?
Add my crab, and let's say that when it stands up, this is where the toes touch the ground. They just got to touch the floor right here.
Okay.
Okay,
Uh-huh.
so what is the distance from here to here?
Oh, I see.
As if both circles are centered at the origin of the robot.
Okay, so from the center, how far is the feet out?
From here to here is the coxa distance, and from
Right.
this to this toe is what we want to know.
Okay.
Um, But I
Uh,
have this as a pose, and I have this as a pose, so I can do that mathematically
yeah, you could just
in
measure the
the
distance somehow.
yeah, the first time it happens.
Oh, also,
Um,
one other thing to think about is like when we make it stand up or whatever we want it to do, the closer
uh-huh.
the tip of the foot is to the body, the less torque there is on the femur. So that's something to think
Very
about too.
true. Very true. The further out you stand, the more power it takes. The same way it's
Yeah.
easier to keep your hands in when, like I go swimming a lot, and
Uh-huh.
when I lift myself out of the pool, if you put your hands in front of your belly button, you'll have a much easier time than if you put them straight out, right?
Right.
There's torque involved. Yeah, like you said. Uh, so first, only the first time we stand up, we want to measure that radius. So let's take legs, get first. And I want to know toe, get world, uh, and then because that pause is relative to the center, I can get the length of pause, and that's my radius.
So right now you're trying to find the radius of the foot to the center.
From the center to the toe tip, right?
Okay.
And then algorithmically, I'm going to keep that radius distance and and move the toe tip accordingly. And if we have an IK system, then it would pull the leg to match. Um, don't have the IK system yet. I used to. I don't at the moment.
I have some of the inverse kinematic equations. I have all of them solved, I think.
Uh-huh.
And I tested it and it works. I was able to give it any XYZ coordinate and the tip of the foot moves to the corresponding
Hello,
distance.
darling. Pardon me a moment. I will be right back.
Okay, no problem. So, I definitely need to work on a final assembly of the leg. Leg final assembly will create a new body, new design. We are going to save this as leg final design. He said it wasn't better. It's not good to do a final design. It's better to do. Let's see. It's not good to do a final design because it's better to number them, which is a good advice. Leg. Let's do V7, right? Because we're on V6 now. We're on V7. We can do insert. Insert a. Let's see. Inverse kinematics. Simulation. Okay, let's just do the. Let's see. How do we want to do this? The coxa. And then we can do a insert V for leg final. We can just import the tibia, I believe. Can we do that? We should be able to. If I click everything here,
Hello.
it's back.
Um,
Hello.
okay. So I have to think a second. I've done this before, and I wonder if I have old code for this back in. I do. I do. I do. Sit down, stand up. Put foot down would get the last point of contact on the floor, and then and then get the target position based on that initial starting spot. So it would set the end effector target position, and then the system, the leg system, is what would actually calculate, move all the bone parts.
Oh, so that's like inverse kinematics, right?
You're right, right, right. I had a separate inverse kinematic controller, and this thing is just saying move the toe to this point, and then the toe, P2, is following this path over time.
Right.
Where's
And
the
are you trying to find those equations that's able to do that?
put foot down? It snaps the toe to the floor, and then that sends the joint angles through to the crab. Um, how does it know last point of contact for the toe? That's just recorded at some point. So, oh, I see. So at some point, like when the robot first turns on, or the first time it goes into the sit-down position, the point under the toe should be calculated once and then stored as like the stand-up spot, maybe. And that is what they're using here as last point of contact, at least initially. Maybe they use the last. I remember using the last point of contact and then the estimated next point of contact, and interpolating between them to produce a lot of joint strategies. Right, like you pick where your foot's going to go before you lift the leg, kind of thing.
Okay.
Does that make sense?
I think so, yeah.
And then what you can do is, whether you're moving forward, back, strafing, or rotating, you change the estimated point of contact. And even if the leg is still in the
Oh,
air, it just adapts immediately
I
to
see.
retarget for that position as time is moving forward. Excuse
That's
me.
good because some of the code they have to go through the entire loop first before it can adjust.
It's not dynamic. Is that what I'm hearing?
Yeah,
Uh,
like they have to finish the if they're like if you were walking forward and you want to turn right or left, they have to finish the walking forward loop before they do it.
because they can't do both.
Yeah.
Uh-huh. Uh-huh. That really slows you down. In the corners? Sure. Um, um,
That's kind of how my when I started the coding, that's how it worked. That's how I did it. It was pretty bad because I had to finish the movement it's doing at, then it's able to change.
uh, uh, great. If we It's not great, but at least means we have to sit down first, and that gets us our points of contact. Uh, and I can put that in the leg. Each leg remembers its own last point of contact, right? Okay, so that can be accessed by anybody, but it's also final, so you can't delete this or replace it. You can only change the values inside of it. Um, and then so here, when it sits down and it assumes this position, then I'm going to draw a line straight down from the toe to the floor, and whatever that is, that's the first point of contact. So, um, toe. This is, I think, clunky language. You having to write matrix helper get position on the world matrix of the world position of the toe. This feels like really janky. I wish I could go leg toe get world get position and just right. To me, that feels easier because this also needs to get all of this crap in here. So this also takes more typing, but that's where I'm at the moment. Um, pose z equals 0, and then point of contact I equals pause. Didn't I just create this? Oh, it's in the leg. Right. It's leg point of contact. It's a point, not a pose. So that will set so the first time it sits down, it calculates the point of contact for the toe, and then after that, in stand up, I can use that point to direct the toe where to go. But that won't do the inverse kinematics. But we can get to that.
We should be able to somehow define our variables for the inverse kinematics, like a femur length, coxa length, and stuff like that, right?
Sorry, try me again.
I said, when we get to the inverse kinematics, we should be able to define our variables, like femur length, coxa length, and tibia length, right?
We have those.
Okay.
Oh
Yeah, we
the
do. That's the nodes.
right. Each node is at the center of, like, from this center to that center. Can I
Oh,
highlight
yes.
these a little better? Uh, so I believe it's from this one to that one, from the front left coxa to the femur, right? And then if I go
Uh-huh.
deeper to the tibia, there's the tibia, and here's the toe down here.
Uh-huh.
Uh, it is kind of better when oh, it doesn't let me turn the lights back off again? Fine. This shadow should be affected by the ambient light, but whatever. So I can get this toe position, and I can illustrate. See, I can't draw the last point of contact in the scene here, and I really want to, just for debugging purposes, to visualize what's going on inside the crab. But I could, right? I could make this last point of contact. I could add it as a pose as a child. Um, but I don't know if that's the next thing to do. So it was moving the position of the toe, and then the inverse kinematic system would figure out where to move the knee and the the femur and the coxa to make it all work.
Right.
Provided that's even a legal toe position. But that was one way to do it. And in the very first crab that I wrote, it was only about controlling the joint angles with a complicated series of. I did a lot of matrix transforms, I think.
And we also you gotta make sure it's
Hmm.
legal and it doesn't go past 0 180 because the servo could try to reach a position it's not able to reach and then
The
burn
inverse,
out.
it's the job of the inverse kinematics to know the joint limits and say if this pose is legal or not. Hmm. When I get this pose, it would be great if I could also say, get me the minimum bounds, get me the maximum bounds, and like give me the limits of the joint angles for each of these joints. And then whoever is doing inverse kinematics never has to see what's inside crab. It just has to work through those numbers. Um, yeah, it's like how do you find the limits of each of these values? They're certainly not recorded in the leg itself. So in crab leg here, there's nothing limiting each of these angles. And that's I feel like this is where you'd want to record those numbers and make them available to your IK system. Maybe I'm getting too complicated about it.
Wait, wouldn't we be able to just give it a point and for it to calculate the angles that it needs to turn and then just see if those angles are between 0 and 180? And if it is, then it would work.
Are your limits 180 in both directions? Because it seemed like we could only go to 110 on one of them before it was going to hit the body.
But we can set every single joint on my hexapod has over 180.
It's how about this? It's a simulation, so let's not
Yeah.
worry about joint limits for now. And if we get it walking, then we can make it safer.
Okay, yeah. That makes sense.
Okay. So you say you already have all the math stuff worked out.
Yes.
Awesome. Can I see it?
Yeah, one second. I'll send it to you.
Da, 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 da.
Zero. We have to change one number because it was one second. I'll send you the code.
Excuse me.
I sent it.
Okay.
Wait, is somebody scamming in your server? What is this?
I had to delete them all. You still see them?
Yeah, they're in the chat we're in right now. But I sent you the inverse kinematics.
Oh, I see it up there. I thought I got rid of all of them. I missed this one. Yeah, I banned that guy instantly. Oh, Jesus. This is the firmware in the robot?
This is Arduino IDE.
Right. I get that. But this is
Oh,
what's currently running in the robot?
this was a test. This is not currently what's running in the robot. But this is inverse kinematics to where I can input an XYZ coordinate and then it'll know to move the foot to that XYZ coordinate. And the inverse kinematic,
It'll turn that into theta 1, theta 2, theta 3.
yes, theta 1 is coxa, theta 2 is femur, theta 3 is tibia.
Okay, and then I don't see anything in here that mentions the length of each bone. Is that
It,
the
it's on-
ABCs?
it's on the yeah, it's where look at the link links. A is femur, B float B is tibia, and then L is the coxa offset, just coxa length.
Femur, tibia, coxet, offset. Oh, I see them up there. Okay.
Yeah, and we have to change.
Hey, here's a fun thing you can do.
Yeah,
If you, something like this. See that bubble I just put in there?
yeah. How did you do
If
that?
you do three tildes, a tilde like this, and then do three more at the
Oh,
end of your block of code without the word Java. Everything in the middle will be auto formatted in Java language. You could probably write Arduino there, or you could write just C, and
huh.
it'll do a pretty good job of that too. You can edit your previous comment, and we'll see the color change.
Wait, what is that? Here, I'll just copy and paste that. Tilde. Because I don't even know where that is on my keyboard.
It's above. It's under Escape.
Under escape. Huh. Well, I have a 60% keyboard and I can't see it.
So it'll look like this if I do C.
Oh, I see.
Yeah, color makes a big difference. Um. Okay, I have to adjust A, B, and L to be what we've got over here.
Yeah, the only thing that needs to be changed is, I think A. The femur needs to be 150 instead of 200.
Um. This is XYZ of the toe position. Right. Okay. Um. And that would be a excuse me. And then we had the ABC up here. No, that's DRC. I wanted ABC. ABC. Do 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 do. Do 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 do. That's what I want. Why are you being difficult? Okay. But this is we had this from before. That's femur, coxa, and tibia from up here. I hope that's right. Um, this would be double. This would be whoop. This would be double. This is math. Just grab that. Dot 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 dot. Nope. Dot 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 dot. So then in theory these are our three angles, and then it's set, leg, pose. Uh, so maybe this should also be the leg index. Uh,
But this
uh,
this inverse kinematics is very specific to how I calibrated the servos, like where the zero position is of the servo.
I'm not sure I followed.
Let me think. I think I have a because these angles, the servos start at zero and they go to 180, right?
Yes, you adjusted the zero position for each servo individually, so they're not actually zero. It's like one of them is centered at two. You need a calibration offset in your joint values.
Wait, let me see. I think I have
Yeah.
a picture of where my zeroth position is. It should be on my YouTube channel. I think I made an inverse kinematics. I'll look for it real quick. Okay. If you, this is the zero. Okay, so for the coxa, I set the straight. It being straight out, just being 90 degrees. So it has 90 degrees to the left and 90 degrees to the right for the coxa. And I sent you the femur and tibia.
What? I mean, I see the picture you shared, and I see the code. I'm not following the rest just
So
yet.
okay, do you see the tibia? If you take the tibia and make it straight with the body, like I think that's how it is right now. In the wait, no, it's not. If you make it straight with the body, that's how I have the 0 degree for my servo.
Okay. That's that. I can't do anything with that information at this time.
Okay.
Um, uh, so I do think that's useful. It's too soon for me. Um, why is this angry at me? Why is this all nasty colors? You're mad, so you're mad? Come on, that's... Why is this mad? Implicitly declared classes. What are you talking about? What has broken here that causes this error message? Oh, it's an extra parentheses. Wild. Um, move toe for one leg. So this uses the code that you described, and hopefully the right measurements, and then sets the joint angles for each of these. It's not set post, it's set pose for one leg. And it's not just setting these angle values, it has to actually move the leg. Where is it up here? Not the bones. Set leg pose. Right. No? No, that sets it initially. Where's the one that's like rotate Z, rotate Y, rotate Y? Rot Z. It's in leg now. That's why I don't see it. It's in the other friggin' file. It's set angles for one leg. Right. Coccyx femur tibia. So back down here, set pose for one leg. This is stupid. This is legs get eye, set angles. Here are your three angles. And leg index, set angles, theta 1, theta 2, theta 3. So this moves the toe to this position and should move the joints if your kinematics are looking good. Now, I wish there was a really easy way to say this point is always going to be a certain. Yes, there is. Yes, there is. Um, move toe for one leg. Right. Okay. In leg, we had last point of contact. This should be point of contact last. I see why they wrote POC, but yeah. And new point, yeah. Da, 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 da. Did I need that for here? I had a reason I needed that. I'm not making my thinking clear. Um, um, I have to review the plot. Now that I have moved toe for one leg, my animation here, like stand up, can use that. Move toe for one leg. Move toe for one leg. In sit down and stand up, right here. I can move toe for one leg. That would be leg I. And the position of that toe is next is leg I, next point of contact, last point of contact. Uh, but then I want to go up. I want to go up. I want to go down. I want to go. I want to set the toe to that point, and then I have to raise the body while keeping this where it is. So then
Well, you're
while
making it stand up, right?
yeah, so
Okay.
I'm telling the toes to sit. I'll try running this and just see if the toes actually snap to the floor and if the joints work.
Okay.
So yeah, one thing at a time. That's already
And
a lot of
then
code this
basically
morning.
once you get the toes to sit on the floor, you want the toes to stay where they are, but the body to rise, basically. That's what you're trying to do, right?
Yeah, 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 yeah,
Okay.
yeah. Yeah, you get it in one. Clever guy. Okay, and there's my stupid floor, and it is not currently touching the floor. Um, is it in? It's not in stand-up mode, is it? It is not because I don't have a way to change this just yet.
And
Um,
what should we be seeing right now? We should be seeing the foot on the ground.
um, 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 yeah, of course, it's just a. Okay, I will come back to that. Um, this is currently not moving because it is hard coded to be in sit down mode. If I change this code in here, and this is one of the reasons I love Java is that I can make changes in real time like this without having to restart. So clearly that has gone the wrong way. Um, where does it think the toes are now? Um, yes, that is where we want the toe to be. Actually, we want a toe target is what we want. When we move this new position, um, we're currently doing hard-coded numbers. Wait, how do I know that that's going in the right order? Um, just to be on the safe side. Well, that didn't change anything. So if I go back to this thing here and I go sit down again, excuse me. Sure, so that still works. Um, so something in stand up is wrong. We knew that. Um,
Wait, are you doing the stand up right now?
Uh, I am trying to do the stand up, but before that, I want to add a little button on the left side of the screen that I can click to change the modes.
Oh, I see.
So crab panel, here's the body that I want you to have, and then I'm just going to rip off a whole bunch of these bits.
And to
Um,
do the stand up, you're using my inverse kinematic equations, right?
I'm trying to, yeah.
Okay, and the only thing that I don't get, I think, is how does it know? Okay, once it gives out those thetas, how does it know where those thetas are starting from? Do you know what I mean?
They all start at zero. What do you
Yeah, but
mean?
how does the like what would be the zero position for the leg of the robot?
As illustrated when it first wakes up before you go into sit down mode, when the legs are straight out. That's how
Okay,
the model sees it by
okay,
default. What would happen is I would
that's
send you a list of 18 numbers, and in the firmware, you would adjust by whatever amount you need to calibrate so that your real model
oh, I
matches
think
the
I see.
computer model.
Okay,
That way it's done
so
because your hardware is going to be different from the idealized version.
right.
Yeah.
So what I don't know if this is if you I don't know if this is helpful, but the picture I sent you, that's how I calibrated my servos. That's how the inverse kinematics should be paired up with the angles, where the tibia is straight out, which is what we have, I think, but the femur is pointed straight down.
Right. So my position isn't going to match yours because I need to do calibration to the inverse kinematics. I need to change the numbers that come out of it so
Yeah,
that
so
our
that's what I
two
was
systems are in sync.
yeah, that's what I was trying to say with the
Okay, I
picture.
got you now. I got you now. So if I make this do nothing, it's not going to go anywhere. But if I start it in do nothing mode, we'll see it in its default position. In fact, there should be a go there, do that. For all of these, uh, legs get I set angle 0, 0, 0. Well, that was easy. Okay, back in crab panel, I want a selector. Um, that does not look like the kind of selector I want. That's a range. That's a number slider. No, I do want a range. It's the range is the angle. Add, where did it go? Really? None? Okay. Add a dial. In the limb panel, there was a dial. Create dials. One dial for each joint in the robot, right? But it's not, that's the angles. I don't want that yet. I just want a selector in here. Um, what's the friggin' name of the, my brain is not working all of a sudden. In mesh instance panel, there is they got these render styles, and then the render styles go into a combo box, and the combo box is what does the thing. Right. So if I drop this here, um, and it's the walk modes that we have. So it's do nothing, um, zero position, sit down, stand up in that order. It has to match. That kind of sucks, right? But it's first draft. Um, it's not render styles. It's walk styles. Has to match the enum. Where'd that enum go? This one has to match crab walk strategy. Note to future self, right? This is oh, it's just an array. I can just skip all of that. Oh, it sets the initial value. I see. I don't need to worry about that. And then I've got the component and listener. So yeah, I don't need to. Initial value. And then when it is changed, that is where I would say here is where I say change the movement style. What is the style called again? A walk style? My brain is chosen strategy. Yeah, change walking strategy, change chosen strategy. Public void set chosen strategy. Nobody, anyways. Okay. I think so. And then this is crab set chosen strategy. And then it's based on oh this has to match exactly like letter for these have to match exactly the value like the name of where the hell is it? All the way at the top of the file. These have to match exactly to this bullshit. Um, okay. And then I think I can just comment a few of these out so that they don't happen. Okay. You don't exist here. We're not doing that. Okay. My brain is not as clear today as it was yesterday. Add a crab. And now when I go to crab, I should... Oh, no you don't. Where are you? Where did you go? Look at, we'll have a way to create a... There it is. That's what I'm missing. Crab has a method that returns a crab panel for this robot. That's how I get the panels. It's not great, but it works. I always go there instead of, like, I wrote this app and I'm using it wrong every time. There's something intuitively incorrect there. There's my crab button, right?
Nice.
Zero position, sit down, stand up. Okay. So now I've got the button. Now I have to make it do the thing.
Are you gonna work on this stand up next?
Yeah.
Okay.
Yeah. So set, choose, and strategy, which goes through here, which goes to this. So if I take this out, okay, now, okay, can I get away with running that just like that? Boom, bam. Do nothing. Zero position. Sit down. Stand up. Do nothing. Zero position. So zero position is wrong. Okay, zero position. Um,
I think one side is right, the other side is just because it's not mirrored, maybe? Wait, actually,
this
should
this
you
is
should you set the zero position to match how I've calibrated my servos? Whilst if we don't, you would have to change we would have to change the inverse kinematics, right?
I'm sorry, I didn't follow that quite right.
The zero position for the legs. If we change those to match with the picture I sent you, then we wouldn't have to change the inverse kinematics. But if we don't change the zero
Yes,
position, then
yes.
we would have to change the equations.
The first thing I noticed here was that as part of that is, if I recreate this grab, so add this. So when I say zero position, they all snap to this direction. First thing I have to do
Yes.
is make them point outwards correctly, and then I
Yes.
can adjust the femur and the tibia to match your model, and then the
Okay, yeah, that makes
kinematics
sense.
for everything else should be okay.
Okay, yeah.
So here in when I position the legs here, I give these 6 Z values, and those are the starting angle values. Um, um, I could, and I think I should. I see how this could be made into a list of names, and this could be made into a list of translations, and then this could be put in a loop, but I'm not sure that it's worth it to invest that much energy at this second. So I wanted this starting Coxa values dumped up here because when I do zero position, yes, this should be like so. And I probably have to restart because I added a global value. Oh, sorry, a value at the top of this class. You can change things inside a method, but you can't add a global value. That's not a global value. You can't add a class level parameter and you can't add new methods to a class. Anything else you can get away with. Um, add a crab. Da, 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 da. So here's my crab. Here's my do nothing. Here's my zero position. Great. Here's my sit down. Also great. Here's my stand up. No. So back to our zero position. Um, set angles A, B, and C. Let's try. So the picture again. That is where both the joint angles are at zero.
What? Actually, no. If you look on the picture,
Yeah.
if you see letter A right next to it, there's
Yes.
180, and
I
right
see.
above that is zero. The zero,
Yes.
that line, that little line going straight out. So, okay, basically
Yeah.
right now in your picture, the tibia is correct. The tibia is the zeroth position. That's basically right. Do you see what I mean? And then if you look below the
Right.
A,
Okay. But where A meets the origin, what is
right,
that? Where is that at when it's at zero? Is it
it's
straight
pointed
up?
straight down, straight down. Straight up is
Straight
180.
down.
Yes.
Oh, I see the zero now.
Yeah, and above that is the
Oh,
180.
okay. Okay, okay. So in femur, it might be this way. We're gonna see. That way is zero.
Yes, yes, yes. That's the zeroth position for the servos. That's how, yep.
Okay.
Wait, not for the coxa though. Coxa, that would be 90 because I want obviously 90 on one side and 90 on the other side. The coxa, the shoulder, do you call it the shoulder or the coxa is at 90 degrees right now.
That's the only one that I rotated. So you wanted it to be this way, and you want the tibia to turn downward.
No, no, no. Like how you had
No.
it just now was good,
Yeah.
but the
Right.
coxa joint was at 90 degrees. It's not the zeroth position for the coxa. Like if you look at the coxa,
The coxa is this piece.
yeah, yeah, they're pointed straight out, right?
Sure.
And we obviously want 90 degrees to one side and 90 degrees of freedom to the other side, right? So that's not
Right.
the
Plus
zeroth
or
position.
minus 90.
Yes, so that's 90 degrees. That's a 90 position. That's not the zeroth position right now for the coxa.
Oh, because you
You see what I
keep
mean?
all your angles as a positive value. You don't allow positive and negative 90. You go from
Yes,
0 to
yes, yes, yes.
180.
Yes, that's how I did it. That's what makes sense. I don't know if there's a different way to do it that's better, but since the servo angles are from 0 to 180, that's how I did it. You see what I mean?
So
Yeah,
that's
that
them at 0.
basically, but one side is it's obviously like not mirrored. So one side is correct, the other side isn't.
Um, yes.
And that's the thing, like, remember we talked about yesterday? You said that instead of having to, if we didn't mirror it, like now, if we didn't mirror it, we only had to change three things, which is the three cocks on the other side. Wait, give me 1 second, I'll be right back.
Uh-huh. What?
Hello, I'm back.
Hey,
Had to help my parents with something. So, what are you working on now?
um, the panel. I just tried to make it sit down again, and I'm still not succeeding. I think I've broken the button. My brain is not working the way it used to. Um,
Wait, so when I was gone, you got the 0th position, and then you tried making it sit down?
yeah,
Okay.
that's get and set. I have to reboot because I added a new method. Get index of. I have to do something stupid about like counting them all. Uh, I don't need to send it the crab. I have that. It's not render style. It's walk style. Then it's um, why would it? If these names match, that's the index we're looking for. We set that strategy. Right. So this sets it initially whenever the panel opens, which is frequently. And then this one allows us to change what's happening in the crab. So first, here's my crab. Then here's my button, and I change this to 0 position, and then I move away, and when I come back, it's still 0 position
Wait,
as
one
it
of
should
the
be. Yeah, 1, 2, 3, and then this one's the wrong way. So
there's two that's a little
I
wonky.
think what's actually happening is here when I invert, it's all the way at the top. Whoop. When I invert these three, it's actually 2, 4, 3, and 4 that are inverted. So remove you, add you again, pick the crab, and change that to 0 position. No, it's the same again? If I turn this off, and all I had to do was hit update.
Also, the 0th position. That's like where the angle is 0, right?
Yeah.
Okay,
We're trying to adjust it so that when I say 0 position, it matches your model.
right.
And you told me that actually all these should be at 90 at the home position. It's not the 0 position, it's the home position. So,
Wait, one second. The servo? The right side of the servo. If the horn is pointing straight towards the right, it would be 0. Straight towards the left, it would be 180.
um, I'm not sure I followed. Yeah, no, my brain was on another train of thought.
It's okay. Like if you go to the
I,
render real quick, this might be kind of
if I disable this flipping of the coxa completely.
like if you just look at the middle two servos, right? So okay, so if you
The
look at
center servos.
if you look at the left one, if we just look at the left one, that
Yeah.
position on the servo, that would be 180. The other way would be 0 position.
Okay, yeah, so these three are correct and these three are wrong.
Mm,
Which is
they're
this one,
all
which is
they're all
this one, and this one.
wait, they're all on 180 right now.
They're
Because it's
all
not
on 180.
yeah, because it's not mirrored. You see they're all going to the same way.
Uh-huh.
Relative to the servo, they're all on 180 degrees. So everything
Um,
is right, but you just gotta
um,
because one side, like the looking at the render, the left side is the left side should be on 180, the right side should be on 0 degrees, basically. Because they can't all
that
be
has
on.
me so confused. Give me a minute, please.
Okay.
Um, I don't set those positions here. I set them in position legs when I set leg pose, but that's for like the first time I set them. Um, that value there is um, I only want to do this the first time and never again. Maybe this is initialized leg pose. And then here, what was the Cox adjust is also this, so that I'm trying to get that the adjustment value. So when I give it 0 degrees for each angle, that's what actually comes out on the other side. Um, no, I'm not phrasing that clearly. Hmm. Oh, good. Oh, good. I'm getting dumber with age. So this does not work. Um, this goes from the crab to the label. Set. And I actually need well, I don't need to do it here. I can go through all the crab names. Is that, that's awful. Come on. Get selected index. That doesn't get me to the, because enums are dumb. I can't just turn an enum into a number and back. Um, so stupid. It should have just been, maybe it should have been a button, but oh, I hate writing user interfaces. I was having so much more fun getting the walking to actually work. Um, Sorry, Echo. I'm not trying to freak you out. She thinks I'm talking to myself like a crazy person. I had zero position. Then sit down is different now because those home angles are all messed up. If I go back to zero position, no, I get this again, right? Because it can't do this. Because it can't do this, changing the chosen strategy. I don't know why that suddenly stopped working. Are these walk styles not perfectly matching? Do nothing, zero position, sit down, stand up, right? And in crab walk strategy, those are the same, right? Oh, they're not the same. Ha ha. I made the rule for myself, and then I still broke it. So this isn't zero position. This is, yeah, that's why it dies on me. Ha ha. I did it to myself. Scene add crab. Crab home position. Uh, these ones are turned more than these ones, which are turned more than these ones. That's weird. Why is it cumulative like that? Crab. Um, it's no, it's in the set pose. In initialize leg pose, yes. This is like initialize all legs. Um, is this Coxa adjust wrong? I don't have a direct way yet to poke this number and see what happens on the screen to wiggle it, you know? That's what I really want. Um, Um, don't have a way to display I want to see the value and then wiggle it. Um,
Oh, that's kind of like the other online simulator I had. It had like a sliding bar, and it's able to
mhm.
like slide it back and forth, the angles of the.
See, because right now Crab is storing internal numbers about these values, the pose, and I can't see the pose on this panel. So I can't, and I want to be able to see and manipulate the pose to be able to wiggle each of these joints. And that's not immediately visible. Um, and changing this home position is making me a little cray cray. Uh, you're not here. You're not here. You're not here. You're not here. You're relevant, but not. So this cox adjust is used in the leg to change that position. And then it should also be, you said, flipped for some of them. Um, and it's the direction that's flipped. I mean, did you install the servo upside down on one side to
What do you
flip
mean?
it? How did you do that?
What do you mean?
How did you flip the motion on one side so that 0 is over here and 180 is over here?
I didn't do that yet.
So they all actually turn the same direction and they all have 180 in the same direction.
Yes, the inverse kinematics I gave you, it's only for one test leg.
Okay. Uh, let's try this. These still turn. I don't want them to turn at all. I think I've lost the plot and I need to take a break because this is proving difficult. Yeah, I'm doing something wrong here and I need to think about it. Um, I used to have just this. But the legs are straight down. That's where we wanted them. But like, why didn't it?
Wait, so right now we're still trying to work on the zeroth position. We got the
Yeah,
tibia and femur,
I want
but
to get that. I want to get it to match what you expect for your test leg, for your one test leg.
right.
Okay. So here's center. Oh, sorry, this is all in do nothing mode, right? So I switch to home position. Now we got this joint and this joint in the right location. And now these are all going to 0, which is smashed to one side. So this is when I added this plus 90 in here. So right, they're back in the center position, or what I call center position.
Maybe we
Um,
could go with that and somehow change the inverse kinematics. I
change
don't
it.
know.
Yeah. Mm,
Cause
there's two separate kinematics happening. The rotation of this joint is based on the XY plane under
right,
the leg. The the second is the movement out, right? When you're already on the
yeah,
plane, it's just a distance. It's an XY problem again. And
it'd be a ZY.
and the position that you give is in world coordinates, right? Or is it relative to the coxa? I don't. My brain's really not here today. Um, we have the set toe. We have this move toe for one leg. See, what I don't. My problem here is that I can't visualize this. If, as a for example, in 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 the Mecha 500, I'll put the floor in again. In the Mecha 500, um, inside here I have a limb solver
Hmm.
and a target. And if I move this target while there's a bit of forward velocity, it wants to move to
Oh,
match this target.
I see.
If I rotate this,
Oh, I see.
and that's the kinematics we're talking about, right? So in a perfect world, I would have an easy way to, instead of doing this leg, say I want 6 of these on the crab, and then I reuse all of this code. And
Oh, I see. Yeah, that's the inverse kinematics. Like you move it, you want the robot to move to the end effector to move to a point that you want, and it's able to calculate those angles and move to that point.
yeah, exactly, exactly. So, but more to my point, I can see this on the screen. I can visualize these lines, and that helps me think about the problem and figure out what's going wrong where. Um, Currently in our crab,
Are we able to add those lines?
that's the thing, not easily, and that is unfortunate. Um, I agree that it needs to be done, but it means we're not moving forward as fast as I might like, and I have to live with that. Um,
So the only thing right now is that we don't have those like straight lines to visualize, basically.
Correct. Oh, I'm still locked. That's why I'm not seeing the thing. That's where it thinks it is at the home values that we've given it, because we adjusted that bottom angle there.
Yeah.
So in sit down, this is not this is another minus 90 maybe. There you go. Okay, and now that it has sat down, it has recorded the last point of contact, and I don't see any reason why we can't make this the next point of contact as well, because that seemed to be a very successful strategy in my old code for simulating crab. So here again, I would love to be able to paint a circle or a marker of some kind that shows the last point of contact and the next point of contact and verify that they're actually here under the toe. Um, this is OpenGL3, and in OpenGL3, you have to package everything into a block of data, all your vertexes and your graphics data. You have to package them specially and then send it to the video card. And if it has the right shader, then it will do your thing for you. Whereas um, if in OpenGL2, all I had to say is, hey, I want to draw a point and some lines, and it would go, okay. It took like 3 lines of code to make it happen. And here in
Hmm.
OpenGL3, I get the shadows, okay, but drawing debug information is awful. It's not quick, fast, or easy. Hmm. What is it? Quick, easy, cheap. Pick two. So I got none of them in this particular case. Um, so I have to trust that these work. Uh, so this is our kinematics model. When we move toe for one leg, maybe if I set this for just one leg, just one leg, please. Hmm. So it put the toe down, but it doesn't appear to have worked. So then we get to this block of magic, and I don't know how to debug this because I can't see what it's doing. How do we make this work? What, for instance, what in your picture? Where's D?
One second. D would be. Oh, dang it, my iPad isn't charged. Wait. Okay, so D is the distance from the horizontal distance from the femur to the tip of the foot.
From the
From the
you mean from the
femur
shoulder
axis,
joint or from the hip joint?
the femur joint. I'm not sure which one. I think the hip joint, or from the femur joint to the. It's the
In your
horizontal
picture,
distance.
it's the joint on the far left.
Yes, yes, yes. From that
That's the
joint,
hip, and the one at the top where you between 180 and 0, that joint
that's
up there is the knee.
yeah, that's the yeah, the femur or I mean the tibia, but
I'm
yeah,
talking about the joint between the two bones. Right.
yeah, the
Between
tibia.
the fibia and the tibia is, sorry, the femur and the tibia is the knee. So I'm just talking about from the hip joint to the toe tip, and then
But
C
make sure
is
put the horizontal distance because
yes, yes.
horizontal, and then R is R is the total distance. That's that's
Linear
from
distance.
yeah the horizontal distance from the coxa to the tip of the foot.
You subtract the coxa,
Wait,
so you're compensating for it, and you've got these two backwards
wait,
from
Jason. Opposite
toe
is
tip
so we
to
can do B squared. Wait,
crab
wait.
center.
I have a drawing here.
Here, this is to crab center, and this is
I sent it to
minus
you.
the radius of the interior. What is the lowercase or the cursive L in the bottom left?
That's the coxa offset or the coxa length.
Coxa length. But the coxa length isn't the same for all six legs because the body isn't a circle.
But I have
It's
my
different for each leg.
I have my origin set at these. You see my origin? It's the most leftmost. I put a 0, 0 right next to the origin.
Yes, I see that.
Yeah, that's where I had my origin.
That's fine. Um, so what? Um, from the center. So this is from the horizontal distance from the toe tip to the to the uh, to the axis of the coxa to the
It would be the femur? It would be the axis of the femur, right?
femur motor.
In my drawing, that's how I had it.
Femur's the red thing on the left. Coxa's the bit in the middle.
No, no, no.
Is that
Coxa is the red thing on the left. So it's coxa,
right?
femur, tibia.
Right. The coxa motor. The coxa motor is attached to the body and it
Yes.
rotates. Oh, you're calling it the femur motor because it moves the femur bone. So
Yeah.
this is the shoulder motor. There, the shoulder. That's not the right word for it either because it's well,
Why don't we just call it femur?
it's the hip motor. Hip motor. Then this is the from
That would be from the
horizontal
shoulder, I guess.
from the tibia, the femur, the coxa is the bit that goes around the body.
Yes.
Horizontal only from the. It's not the hip joint because there's two different joints here. There's the knee, there's the thigh, and there's a third joint whose name I don't have. I don't have a name for that.
Why don't we call it coxa, femur, and tibia?
I'm not talking about the bones. I'm talking about the joints. So the joint. Okay, okay. I'm sorry. I'm starting to get it now. Tibia joint is never mentioned here. This is the this is the femur
Yeah.
motor.
Yes,
I'm
yes.
getting
Femur
that
motor.
right? Okay.
Yes. And this
From
would be
the
the coxa from the coxa motor to the tip of the foot.
right,
Yes,
and
and
then
C
C
is
is
the distance, not the horizontal distance. It's just the distance from the femur to the tip of the foot.
uh, save image.
Wait a second, something doesn't look
Uh,
right. D is equal to square root of x squared plus y. Wait a second. Is that what I sent you? Am I tripping? Wait a second. To- Wait, if that's my 0, 0, shouldn't R be square root? What? Yeah, wait. That is really weird. Oh no, I think. Wait a second. I think my code is different from the picture. I think my R and D. Oh, okay.
I see you have
So R and D is
edges C
switched.
and D.
R and D is
In your
switched. That's it.
R and D are switched.
Yeah, so the code, it's R
Oh,
is
oh,
the
because D has
picture's
been
D.
drawn in a funny place. D should be drawn. What's the way to draw that?
So if you just flip the if you just flip the
Hold on
comment
a
on the
second.
R and D, it should make sense. Put the comment where the R is, where D is, and put the comment where R
Um,
D is to where R is. Because D should be the horizontal distance from the coxa to yeah, that's right. So D is the horizontal distance from the coxa to the tip of the foot.
um, like yay.
Let me see. Yes, yes, yes.
Take a screenshot.
One second.
F12.
Okay, I got it.
Cool.
So just D and
Um,
R switch. That's it.
right. Now, what are you calling the line from the corner of from the right angle? You got edges C and you got edge R. What's the third side of the triangle called? It looks like it says
C
minus
R.
2.
Oh, that's a negative Z. That's a negative Z. Because Z
I
is up and
see.
down. So that'd be negative Z.
No, we're not putting negatives in here yet. We're just putting labels. That's a C. That's a right angle. That's length B.
Wait, I think your
That's
stream is
length.
frozen, maybe?
I'm not doing
Oh,
anything
okay.
there. I'm writing. I'm writing on a notepad in front of
Oh.
me. Yeah, old school style. Um, this is A. Okay. The angle at the shoulder. This the angle that we want. Theta. Theta zero. No, it's theta one because theta zero is coxa. Theta zero. And this angle. This angle. This is theta 2. So, like this.
Let me see. Uh. Okay, Z, C, B. Wait a second.
I'll just take a picture with my phone. Rotated it. Put it in general.
Okay, let me take a look.
Sorry, it's rotated.
Okay, theta. Wait a second. Oh, wait. Coxa, you're calling that theta 0 and then theta 1 and theta 2, right?
Yeah.
Okay. Theta. Theta 1 doesn't look right. Oh, yeah, theta
You
1's wrong.
because you have your zero angle pointing straight down.
Yeah. And you're going from
Yeah.
the horizontal, I think.
Yeah. You're right. Oh, it was so close. Try that again. A, B, C, theta 2, theta 1. Uh, uh-huh.
And to calculate theta 1, in your case, theta 1, the femur joint, I had to add together two other joints that I calculated from trigonometry, which I called alpha 1 and beta. Because there's not a direct way you can just compute theta 1 with a femur angle.
Okay. Edit this picture to rotate it the correct direction. Done. And send it.
Coxa body, coxa theta 0. Okay, so femur, yes,
Mm-hmm.
dr. Yeah, I think it looks right.
Mm-hmm. Um, um,
BC.
I'm giving it a toe in world space, and I am giving it a shoulder value in, I can give it the position of the coxa. So you're given coxa world and toe world space, all in world space. Okay. And you need to find thetas 1, 2, and 3. Um, you don't have to find theta 0. You just have to find theta 1 and 2. Because we're treating it as though it's on a plane. It's all on one flat surface.
Wait,
And then
are you redoing the inverse kinematics?
I'm just checking that what we have here works correctly.
Oh, okay.
Um, I wouldn't use inverse kinematics here. I would use intersection of circles and give it the two bone lengths, and that's how I would do it. But because I don't know how to evaluate this math to check if it's correct. All I know is that when I run the set angles, move toe for one leg, I don't get where I expect. Right? What if back in here, this is stand up, this is toe for one leg. Um, that spot is supposed to be on the floor, and the kinematics are wrong because it's way up here. So yeah, all I can say is I know those kinematics aren't working for this model, but I don't know why.
Okay.
Um, uh, so this when I'm looking at this picture that I've sent you, this drawing, which X is directly along the line of D and R, and Y is sorry Z is up and down.
Z is up and down, Y is pointed straight to the right, and
Okay,
Z and X is coming out at us,
Uh-huh.
out of the page.
That's annoying. I like it when it's X and Y because I'm used to thinking in X and Y for 2D mathematics, which is how we simplify this problem down. Um,
Well, we can test that the inverse kinematics is working. So right now, the tip of the foot, are you able to give it like a X, Y, Z point?
yes, I'm doing that already. That's why
What
this one leg is up here.
what's the XYZ you set for this leg, for that foot?
Right. I can't. It's supposed to be the last point of contact under the toe because I can't visualize that toe position. I can't confirm that this is wrong. If I saw a mark on the floor here and I was like, oh, there it is, then I know that this is wrong. I'm just trying to eliminate suspects, right? Um, how annoying that I can't see that information easily.
Wait, instead of doing the last point of contact, are you able to just give it like a physical XYZ coordinate?
I can I can set a fixed position, yes. Um,
And then if we did that when we know if the inverse kinematics is working to eliminate,
I can set this to a specific value right now. Yeah, you're absolutely right.
if we did that, then we would know if it's working or not.
New point 3D. That's all zero values, right? So wait for it to build. There.
So that one obviously doesn't work because the foot can't physically reach that position of 0, 0, 0. Try 0. Where did the foot even go?
Wait. Yeah, it's vanished.
Can you try 0 and then Y? Wait, 1, 1, 1 won't work either.
Okay, well that bone is still there. Right, you're there, but you've
Wait, the XYZ, is that in centimeters or millimeters? Like that 1, 1, 1.
millimeters.
Okay, so
No, in my app it's in centimeters.
yeah, okay, so a can you try X to be 0? So and then Y to be try 20 and Z to be -20. Okay, so it's
Oops.
okay, yeah, this is right. That's right. That's right. I think we're close. If you put it to oh, that's your 0 position. So put X to be 90 then. Wait, maybe?
Can't
Huh.
solve it.
Now it's weird.
So see, what would be
Oh wait,
fantastic
not
is if
90. Wait. X being 0 should have it pointed straight out. I don't know. That's weird.
um, up here, do walk strategy, chosen strategy, legs, add a leg, and then after I add all these legs, or into each leg, I want to add a right. That's where I want it to go, and much like the toe. Where does coccyx get added to the body? It doesn't. It can't be. The leg coxa has to be added to the body outside in crab. Yeah, there it adds the coxa of the leg to the crab. Um, but it could be here. It's crab, add child, coxa. There we go. And also crab, add child, target position. Okay, so now target position is added to the model, and because it appears in the structure, I can see it, I can visualize it as one of the targets when I'm moving things around. Uh-huh. Cox is already used by a sibling. Oh, there's already one in there with that name. Okay. Not a problem. Target position, set name, target position. Ugh.
Also, I'm not like dead set on using the inverse kinematics. If there's like a different way that you know to do it that's better, we could do that too. I just inverse kinematics was the only thing I was able to find online, you know?
Uh-huh. Um, no, we did it that way because it doesn't complain about the toe position. Um, crab leg, target position. Right, it won't let me add 6 target positions. Uh, let's try this. The crab. No, I need to give each leg a name. Huh! There's the center right target position. And if I move that item, so that's the center right leg that would be out there. That's leg 0. I think it's, well, we'll find out in a second. So then back down here in crab, when I'm solving in stand up, or in sit down, whichever one we were messing with last. Home was sit down maybe? No. In sit down, we set these points. In stand up, there we go, in stand up. This point, instead of being a funny number, okay, is going to be, I'll do this. Move toe for one leg, I, and then this will be pause, and pause is from, pause is find find child with name, oh, um, leg names I, target position. That's what it was called, right? In the target position, leg name plus target position. Yes. Find child. Get the world position of that leg. And you don't like that because it's, avoid a null pointer exception if I've gotten the name wrong somehow. And then I'm moving this. It's supposed to, can I just do this for all 6 legs and see any of them move? Test all the kinematics at once. Hello, darling. Have I told you lately that I love you? Am I even in the right mode? I am not. If I am in stand-up mode and I move this, nothing happens. Let's try printing this position. We are in stand-up mode. We are getting to here. We didn't sit beforehand. I have to sit down before I can stand up. Got to get down to get up. Center right. So this is way off. Needs to come in here. And maybe down here. And there's my floor. It's not moving to match. So what I've done is I've given it a position. It's not printing this value. It doesn't reach here. We were in sit down, and then we're in stand up. It never hits here. It does hit here. First sit is false, but first sit should have been true when it was in sit down mode. if I run this again, nothing's happening. If I go to sit down mode, it hits this point, it gets to here, right? It's saying first sit is true, and then later when I go to stand up, oh, first stand has not happened because first stand is false the first time through. There we go. See, my brain is not the working. If I go to sit down and then I go to stand up, honestly, when I go to sit down, it should reset first stand. So I can do it over again. Sit down and then stand up. And where's my, well, my toe position still wouldn't be anywhere. It's random gibberish, right? In my console, I'm still not seeing this printed output right here. So, right, because it never hits this line. It's actually stuck on first sit. It's not hitting. It's hitting here and never getting to this somehow. It very clearly is. Oh, maybe it's running this 6 times, and that's why. So I gotta, yeah, my brain. Wow. App, add a crab. Here's my center right target position. First I go to sit down, then I go to stand up. All the legs should implode at this moment because they're trying to reach these target positions. But if I take one of these target positions, and aha, check it out, check it
That's
out.
crazy.
Okay, so it might have Z backwards somehow.
So the
I
numbers
think
we
everything's
see,
off by 90 degrees maybe. It's hard to say.
the first number is X, right? And your thing.
So that part works right.
Yeah, that looks right.
And it's easier if I keep it like in the plane because then it makes more sense. Um, there's our kinematics. So the way the problem was described on paper, I had to draw this out,
Uh-huh.
and I need to take this photograph. You validate it for me, please.
Yes, I'll check.
Um,
That's a little sideways, but I got this.
sorry. Yeah.
Wait.
I'll turn it and send it again.
This is, you sent me this already, right?
No, look,
Given
compare.
cost.
I'll turn it and send it again.
Oh,
You'll see when I rotate it that it makes.
the angle of the wait. Given cost.
Do us both a little favor and put some oil on that chair when you get a chance.
Yeah, sorry.
That would be amazing. Um,
Okay. Given Coxa World Toe. Oh, okay.
okay, but that's assuming this you've written this was Z and Y. This is your kinematics as you described them.
The picture you sent me, right?
Yeah.
Yeah.
Okay. So move toe for one leg. That's inverse kinematics for the leg. But the problem is that the new position I'm getting here is the world position of what I'm sending is the world position of the toe, and it's actually XYZ in your system here, which is something else.
Is it just that the X and Y switched?
Like, okay, so this value here, this Y value, that's supposed to be D, isn't it?
That Y
What is
value is
this?
supposed to be
Where?
D. Let me see.
So this X, X, and Y, Y, where are these values coming from?
Oh, I see what you mean. Okay, so that's okay. So it would be Y, but
So
once you rotate that about the coxa, then it's not Y anymore because it's not in line with the Y axis, right? Then you have to use a distance formula, which is what I used there. The square root of x squared plus y squared. That's the distance formula. Because okay,
new
so
position is the vector C, or is it the vector from the coxa joint to the toe tip?
it's the horizontal distance from the coxa to the toe tip.
Then
The
why does it doesn't even need a Z value?
z value is like
Uh,
up and down.
okay, well then it doesn't need the X value.
Okay, so D, what is D? D is that's the that's the horizontal distance, right? Wait,
So
what
X and Y are actually are okay, okay. I think I'm starting to get it here. Here's the body,
you're
and
saying
you say for
you're
any
saying
given joint, the
uh-huh.
X vector is pointing to forward on the body or backward on the body.
So I don't see what you're I
No,
don't
yeah, okay. Um,
remember how you asked me why D isn't just Y? Like on the thing, you asked why is D square root of x squared plus y squared?
because it's on the XY plane. Look, what we're looking at the ZY plane, not the XY plane.
So we're looking at the Z.
Yeah,
Okay, so
yeah. So what I'm
Z
where I'm
Y.
trying to go is where I'm trying to go with this is um, I new position X and Y. That's X and Y values from again. That's relative to the coxa joint to the toe. Yes. New position is vector is supposed to be the from the coxa center to the toe tip. Is that correct?
The new position is supposed to be from the coxa center to toe. I don't know what new position is.
This value when we're saying move the
Oh,
toe for
okay.
one leg,
It's supposed
this
to
is where we
be.
want the toe to be. But that's relative to
Yes,
what?
yes. So the origin it's yeah. What you said is right. The origin
Relative
is
to the shoulder or relative to
it's
the
the coxa, the rotation
coxa center.
yeah.
Okay.
But it's not the
Okay.
center. It's the rotation of the coxa in line with the femur. Like I drew my origin on the thing I sent you and
On the plane of the femur. Yes.
the point. Yes.
Yes. Um, the drawing that I've sent you twice now, the hand drawing, that
Yeah.
is on the plane of the femur. Correct. And the XY plane is looking down on the crab. And so
Yes.
in this starting part, you're getting the that D value, um, and then you're doing a tan 2 to get you that theta as well.
Yes.
So
That's for the
that
coxa. Yeah.
yes, yes, yes. Uh, angles in degrees? Oh,
Yeah, because it count.
right, right. Math 2 degrees. Every one of these can be turned into
Oh,
something
it's
that's
different
a
because you
little
don't need
more
that.
human readable.
Yeah, in Arduino, I just had to put 180 divided by pi.
Can't I just add these together and then convert it to degrees like that? Uh, do, 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 do. Uh, do, 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 do. Okay. And this looks like it's doing a squared plus b squared over c squared,
Yeah, this is
over
law of
the square
cosine.
root of like yeah, and then occasionally you can get you get two values back, don't you? Positive and but you've chosen one, hard coded it in here. You just selected one, and that's it. Um, okay. Oh, I see. Angle femur. So okay. Yes, I follow this now. And I apologize for taking so long to pick up on this. C is the Z plus the R. Uh, okay. Okay, so this new position is meant to be right. So this is leg I, leg coxa, get world. Wait, there's a get position? Is that global? Get the local position. Ah, screw you. So now I subtract the coxa pose from the toe tip pose, and that should get me closer to the correct value. Fingers crossed. Still seems like there's a sign flipped in there. What if it's like this?
Oh yeah, remember? I think you got rid of the z, the negative z earlier.
Okay, so now I put a Z in here.
Wait, huh?
You've got a negative Z
Yeah,
here as well.
I have a negative z there because that's in the negative in my negative z direction. So
So
I don't.
maybe if I do this,
Wait, this would. Wait, how? Wait, what is the purple thing you're dragging? Is the foot supposed to follow
that is the
that?
target position of the toe.
Okay, so
Yes,
that's where
it's,
the.
it's trying to
Okay.
follow that.
Wait, can you? So is up and down correct? Just left and right is not?
I have to sit the crab down, and then I can stand up. And when I stand up, I take one target position and I move it out here. And when I start to get in a valid range, the rest of the leg appears. So this is staying on the plane of the leg.
Okay, so we're still something there's still something off with the inverse kinematics.
Yep.
Okay, let me.
Um,
But it's good that you have the little pink thing that you the target position. That's pretty good. We're kind of close. Huh. Wait, I think the negative z needs to be in there. Yeah,
Put it. I can certainly put it back.
because I did the code 2 times, and whenever I didn't put the negative z, it was not working.
Oh, that didn't quite do it.
Huh. Okay, wait.
What I can say is that
Maybe.
this part is working correctly, perfectly.
Okay.
So how
So
do we
the
break
so
this
the
problem down
8 and 2.
into?
Wait. Can Are you able to test just? Wait. Can you go back? We can test. We can look at the femur and the tibia separate and to see which one is wrong, and then we can fix the code based on based on the tibia and femur. We'll just need to figure out like if the femur is acting right or if the tibia is acting right, or if they're both right, or if they're both wrong.
Sure.
I mean. Okay, so 1 second. If we move the purple thing to the left, right?
Yeah.
The femur should, I mean, the femur should move down, but it's moving. So something is wrong with the femur because when you move it
Both
to the
directions are
left,
reversed. Um,
so it would be y and z. Wait, yeah, x is
probably
fine.
it's not just a matter of subtracting. I don't. Well, if I go back to my other crap, is there still any kinematics in here? Update gate for one leg, but that no, that does target position and then somebody else. This guy.
Wait a second. Did you paste all the IK in there?
Sorry?
Did you paste all the inverse kinematic? Wait, let me check. Wait, I think you're miss. Huh.
Where is this located? This is in components, robot component. It's right there. And do you have there's an ARM component, and is there a solver in here? I don't remember. It's been too damn long since I looked at this code. Oh, I used to have the solution in the palm of my hands, and I
Wait,
have lost it because
can
it's
we go
been
to
so long.
the simulation? Can we check if the tibia is going right? The
You want
tibia is
just the
not even,
tibia?
yeah, just the tibia. But it looks like it wasn't even moving. The tibia wasn't even moving or something.
Yeah, because I disabled it, so we could
Oh,
test just one.
oh,
That just like you said.
okay. So
It's hard to tell because the other
yeah,
joint
it's
isn't matching. Hello, honey. It's beautiful out there, hey? Yeah, it's so hot. Now it's so nice to have shade in the morning. I want to try just something a little like this. I don't think that's going to work the right way. Yeah.
we changed the y.
Um,
Change the y to negative.
I wonder if it's something like this.
Wait, wait. What did
Aha!
you do? How did you make it work?
Aha! This value is negative.
Oh, that's
And if I look
awesome.
this way,
Oh my gosh, bro, it's crazy.
uh, uh, so, so now that I have a valid world position for each of these legs, where is this called again? So I need to adjust by this coxapose everything that comes through here. Um, yes. Uh, Okay. Um, um, if the kinematics are unsolvable, the angles will be nan and the leg bones will disappear.
Wait, so now we have the inverse kinematics working for one of the legs, right?
It should work for all, but let's try moving a few of these other. Let's try center left for starters. Yes. Front left, excuse me. Front right,
Does the other
this
plane work
way.
too?
Other plane.
Yeah, like up and down.
Oh yeah.
Awesome. Okay, that's crazy.
Okay.
Okay, so now we confirmed we got the IK for all the legs. And now we can
Yeah.
literally just
So now
somehow
that
make it sit, walk, we can do whatever we want now.
yeah, so now by controlling the pose that we send in here, this this target position, by moving that around algorithmically, we can make the toe go where we want.
I
So we
see.
have the desired target position, the previous position on the floor, the next position we want to be at, and we can interpolate between the two over time.
An
And by
interpolation is just making the path smooth, right? Like small increments.
breaking into little steps over time. Yeah.
Okay. I learned that from
Um,
ChatGPT.
nice. Um, okay. So to review, our six legs here, we get the target position of each one. This is like control each leg individually. This is the do nothing state is what it is. Like go limp. It's not do nothing, it's go limp. Um,
What does go limp? So like if it's walking
you
and
know,
I
like if you don't flex your muscles in your limb, it's
yeah,
limp and anyone can pick it up and move it around like a rag doll.
I see.
Do not control the target position of each leg. Uh, this allows the app user to move them with the on-screen tools and test the inverse kinematics. Uh, okay. Now here's another one. We've set this target position for each toe, right? But unfortunately they're inside crab. So when I move the whole crab, the legs go with it. And what I'd rather have
Is
is these positions
the feet stay in
outside.
position, right?
And if that works, then I should be able to, yeah, no, it still thinks that they're inside.
Are you trying to say like you want the feet to stay where they are, independent from the
Yeah,
body?
while the
Okay.
body moves.
Yeah, that's good. That's making it stand up. It's not doing that.
Because I'm not in go limp mode and I just changed that. It's the do nothing mode now. No, it didn't like these being removed. Let's check. Yeah, it broke when I took them out. That's unfortunate. So let's remove that. Let's add these crab back in, which should regenerate everything. Now this target is over here. Do nothing. Sit down. Do nothing. Whole crab moves. Uh, Oh, it's still in stand up? Why? You're not supposed to be in... Oh, it didn't... If hot swap failed. Aha. Because I added go limp, and I hadn't been ready for that.
You know
Right,
what's
right, right.
crazy? I feel like a bunch of people pass like right once they get out of school, they would not remember any of the inverse kinematics, and somehow you're still able to like
That's
mostly
because I use it
understand
a
it.
lot.
Cause
Only
what?
because I use it a lot,
I see. That's good. Like I
right?
don't know. Like
Like if you didn't use trigonometry in your
uh-huh.
construction job, or I don't know, you'd forget it all. And
Yeah,
then
yeah.
years later you'd be complaining, why did they make us learn this? Um, where did I put the... Oh, it's in the panel. Okay, that has to be changed. The name has to be Go Limp, or everything breaks. Okay, add crab. Crab, go limp. But crab needs sit down one time. Leg. Oh, it was there. There it is. Uh, so that toe target, if I take this one and I put it outside the environment and I move it, it stops working. Interesting.
Wait, so right now we're trying to separate. We're trying to basically drag the body without the feet moving, right?
Yeah, I was trying to, but because of the way it's been built, there's another way maybe. Um, toe targets, toe targets, toe targets. It's in the leg, right? Target position. Target position is added as a child of crab, when really it should be... Crab has no parent at that stage. That's right. Crab has not been added to anything. Crab doesn't have a parent, so crab can't put target points outside of crab's body. Does that make sense? So when I create crab, I'm like, here as an example in the panel, I say, make a crab panel and give it one crab.
Okay.
So when I get to the spot in crab here where I say, we're in crab leg, right, when I'm still building everything,
Uh-huh.
from this first line where it says give me a new crab. I'm
Hmm.
building the leg that goes inside the new crab, and I say crab get parent. Crab get parent is always null in the constructor because the crab doesn't exist yet. It hasn't been attached to the scene. It's
Okay.
not in that tree that you see on the left. So these target positions, when I take this target position and I drag it outside of the crab, somehow it's breaking. It's like it looks the same. It's got the
Oh.
same name, but it's lost the association.
And you're trying to drag
So
it out so that you
so
can
that it exactly
move the
so that
body
it's
without moving
it
feet.
yeah
But when you try to do that,
yeah
it something breaks. But it looks
hmm
normal, but it something breaks. Okay.
yeah, it looks right, but it's a duplicate. It's not the original, and I can't put it back because and I can't seem to undo to get it back. In the end, we didn't do that. That's interesting. Um, okay, so maybe I can't move them outside, which is unfortunate. Um, So if I go to sit, where is this now? That is not where it should be. So right at in the sit command, it should move that target position. Crab panel, crab, sit down.
I'm gonna go
What
check
was
on my
it? Was
3D
it?
printer. I'll be right back. I just
Uh-huh.
gotta make sure it didn't like explode, you know?
Mm-hmm.
Right, be right back. Hello, I'm back.
I got good news.
You did.
When I call sit down and stand
Yes.
up.
Uh-huh.
Oh, sorry. No, sorry. When I call sit down, it sets the target position to the to the tip of the toe.
Okay.
So here I remove this. I add a crab. Here's my crab. I go from limp to sitting position,
Mm-hmm.
and then I check the center right toe tip, and it's right here. So if I go back to limp, and I take this toe tip and I move it around,
Mm-hmm.
it proceeds to follow in a sane way. Right? Huzzah!
Mm-hmm.
Excellent. Um, so now in stand up, if I can't if I can't move the target position outside of the body, that's a problem.
Outside the body? Oh, then basically they move together, right?
Maybe I want leg target position. When I set position, that's no. I want set world. M. The target position shouldn't change in the world. What am I trying to say here? I want this. Um, think. I'm trying to make the body rise in the air.
Yes, and wait, are you able to move the body like while not moving the feet now, or
No, not yet. This here should have, because I didn't sit first, didn't go anywhere. Should fly up into the sky. It doesn't go anywhere. Why?
wait, I don't know if this could help, but is the foot able to freely pivot? If it's not freely able to pivot, then it won't be able to move separately from the body. Do you know what I mean?
No, I don't know.
Like the tip of the feet, is it able to pivot against the ground?
It can't actually push on the ground if that's what you're asking. What is DT now? Cannot find local variable. Oh, well. Uh-huh. And then this is, oh, that is the wrong axis. Of course, it should be, I think. And it's already reached the ceiling. If I think. Then I've got it backwards. It's 2, 3. There she goes.
So basically, you made the body rise. Now you just gotta isolate the feet from the body.
Hmm. Hmm. The body's now over 4. No. Okay, fine. And then here, didn't like that? But that's your last point of contact. Don't you have your last point of contact set? I can't see the last point of contact, which would be nice here, right? Okay, if you're there, why is your red axis huge and your green axis or your blue axis invisible? What has gone wrong with that target position? Probably something to do with what I was monkeying around with here before. So if I recreate this crab, crab home position, crab sit down, crab stand up. Your center is but your target position is fucky. And it is fucky because when is this being reset? So that should move the leg to the floor. And then this reads that toe position again to do the kinematics. And I think something is wrong in here because it is not happy. But the target positions are all like wacky now. Let me try that one more time. because I can't see the point of contact last, which makes me crazy, as I have expressed before. Crab, go home position, go sit down, go stand up.
Oh, there we
Ah!
go.
Did you see? That was
I saw
nice.
that.
Yeah. So if I had a way to say, listen, keep following those target positions, and then I move the body. Let's see if I can do that now. If I go to move.
Oh my gosh, that's
Yes.
crazy. Now you like you can make it all
Boy.
dance and stuff.
Oh yeah. It's trying to lower itself back to the ideal height instead
Yeah,
of staying where I put it.
that's awesome.
And then if I'm mad as heck that the whole thing
Oh,
rotates. But baby steps, baby steps. So the next challenge is to write code instead of sit down or stand up. The next one is to do this one to move a leg, or even just move one leg. Actually, it should be like tap a toe. There should be a mode in here called tap one toe, and we practice just that. Then when you got tap a toe down, repeat it 6 times, but out of sequence, and we've
then
got a lock strategy.
that would be a ripple gate.
Mm-hmm.
The most
Mm-hmm.
common you do know that like you know the most common gates and stuff, right?
I mean, I have a bunch that I made up
Oh, okay.
back in the day. I don't know what everybody else uses.
Okay. Well, the fastest one is tripod gate. They lift three legs at a time. So lift three legs. The other three push the body forward. Set the three legs down,
Right.
and
I
repeat.
call that walk three at once.
Okay. Yeah.
And then there's ripple one and ripple two. The difference is ripple one, you do a single leg until it finishes its step. And in
Hmm.
ripple two, leg two is coming up as leg one is coming down.
Oh, I see. So it's a
So you've always
technically
got
more
two in
efficient.
motion. Yeah, and it's the one that really gives people arachnophobia, which is always a good thing if you ask me. Sit down, stand up, tap one toe. And I've got a tap one toe method done. Tap one toe. Sit down, stand up, tap one toe. Okay, so then here it would be from um, from I am annoyed at myself. I have to keep I have to keep turning off ChatGPT because it has not been playing nice with this IDE, and I blame the IDE. They want to sell their AI solution,
See.
so they don't let GitHub do everything it wants to. Another possibility is that Copilot has just gotten slower. Hard to say. Tap one toe. Uh, um, sure. Yes. Um, no, in an so it hits the floor and immediately turns around and comes back up. What are we trying to? The phase, time and cycle, but by cycle time is a value from 0 to 1, 2 times pi. Yes. That gives us the phase. That is the lifting height. Great. And then we have a uh, vector diff is leg. It's just one toe, and I need the leg of that. I have to make it the first leg because it's just the yeah, that'll do. So this is the leg point of contact next, and I subtract the last. That gets me the diff. Then I diff scale, or is it multiply scale, by the phase, by the time and cycle, by cycle time. Yeah, that gives me a unit value between the start and end. Yes. Yes. Um, because I use this again. So how far to scale along the step? So at the start of the step, it's at the previous point of contact. The end of the step, it's at the next point of contact. And then, and in the middle, it should be at its peak at the top of the sine curve. So then diff add the last point, add the z, and then target position, set that. And then finally, move toe for one leg based on the pose of the target position. And why I have to get this again like that is stupid. Doing this over again is dumb. Excuse me. But let's try that and see what happens. It's not doing it between the target position and the position on the floor. Unless it thinks that is the position on the floor, which is inside the floor, which is unfortunate.
Wait, what should it
Uh,
be doing?
so it's bouncing up and down between the previous target position, the previous point of contact and the next point of contact.
Okay.
And that looks correct, but because they're both in the same spot under the toe, it just looks straight up and down. If the next point of contact was somewhere else, it would be making an arc to that spot and then instantly teleporting back to the beginning and doing it again.
Oh, okay.
So if I say, because this is the first, maybe it wasn't 5. Maybe it should have been See?
And wait, is that what you wanted to do? It's going in an
Yeah,
arc and
so
it's
it's
teleporting
going,
back.
yeah, it's going from the last position to the next position.
Oh,
At the middle, it's the height of the arc.
that's almost like a step then, right? That's
Yeah, exactly. Because I can now
just like a half
control.
circle.
That's why here I'm changing the next point of contact, and you see it go from the last
Oh,
to the next, and then
yes.
teleport back, and the cycle repeats.
Yes, and it should teleport back in a straight line so the body doesn't wobble up and down like what my code had, right?
Um, Ideally, the target points stay where they like. As soon as the toe touches the ground,
Hmm.
the last point of contact gets updated to that spot.
Oh, I see. I think you can repeat the loop, kind of.
Right. And you would move the next point of contact immediately. But this is so
Oh, and then you don't have to move in a straight line. You can move it to like the left and then a walk to the left or whatever, right?
yes, you can like your strategies for from your controller to your on one level you have a leg controller that moves from a start to an end point. And on another level, you have the thing that reads your joystick and decides where to move the next point of contact to get the
Hmm.
walking motion that you want.
I see.
Okay. So that was my whole afternoon at the computer. I think it's time to take a break. But
Okay. Thank you so
I think we've
much.
made good progress, right?
Yes, yes. We got the inverse
Um,
kinematics working,
yeah, and if I turn this around,
which my code was almost correct. Just a
and we
negative
got it for
sign.
all six legs. Yeah, yeah, you did a bang up job, man. That was a lot of hard work. Yeah, Heike,
Yes.
check out this Force with his help.
Nice.
I want the other one. I want the screen recorder.
Also,
Yeah, have you ever used screen to GIF?
oh, I haven't. That's a thing.
Yeah.
Huh. Also, you should send me your YouTube channel, and then I can put it in the description.
That was pretty good. Absolutely. Happy to. I realize I'm using the word absolutely a lot of times when I just mean very much yes.
It's okay. I mean, it's
Um, I put my YouTube in the general chat.
okay. Let me see. Awesome.
So we are today the eighth month, the 10th day. When I take progress pics or GIFs, I name them the date and then the number of picture on that day.
Wait, can you repeat that? You name it how?
Whenever I make a progress pic
Uh
for
huh.
my diary of sorts,
Uh huh.
I give it the date and then the number of picture on that day.
The number of picture on that. Okay.
So if it's the first picture of the day, it's 01.
Oh, I see. I
It should
see.
probably be 00, but the whole calendar's one based, so I'm going to go with that.
I see. Okay. Well, thank you for working on this.
One piece at a time, right? We're eating that,
Yes.
chewing that elephant right up.
Yes. We actually like the inverse kinematics. Everybody gets stuck on that, and we got that done, and we made it stand up.
Mm-hmm.
That's awesome.
Mm-hmm. And we can
And
do
we
it,
got
we can do it better ways, but little victories. Yay!
yeah.
Ah,
That's an awesome GIF. That looks so cool. Just whenever you are next available, whenever you're free, just text me. Okay?
okay.